Hey there, we're back. Now we got to find the test statistic, and as you can see, I've already done it, but let's talk about it. So I used the formula, but instead of using the numbers 1 and 2, I changed them all to male and female because that was what our groups actually were. Of course, you could leave them 1 and 2. It's not a big deal, but... And then I took the difference in the x bars. So the x bar for male was 1.6, the x bar for female was 2.8. It all came from this table right here. And then 2.9 squared and so on. And then you're thinking, okay, well, where did the negative 3.29 come from? Well, that's what my glorious Excel is for, right here. It's a rather large formula, so let me bring it up. So it's C4, which in my case, here, I'll just do it again. It's C4 minus C3, so take the difference in these two means, C4 minus C3, and then you close your parentheses, then you divide it by the square root, SQRT, and then you say D4, which is this one, 2.9 squared divided by 182 plus 3.6 squared divided by 150. All there with cell referencing. It's glorious, isn't it? Okay. And while I'm on the subject, I'm going to put alpha in here, which was 0.05, because I'm going to need it for this critical value calculation that I will do in just a second. Okay, so that's where the negative 3.2953 came from. It's kind of annoying, but we did it. Now I'm going to do the classical approach and the p-value approach. I'm going to do both of them because they're both useful. So the classical approach says to determine the critical t-value using the smaller of n1 minus 1 or n2 minus 1 degrees of freedom. So that's where I was right here in Excel. Okay, so the thing about this is you can all see, hopefully, that the women's going to have the smaller of the degrees of freedom because it would be 149 for that, whereas the males is 182. Now, me, I'm lucky because I have the new Excel. My Excel is Excel 2010. So I can do t.inverse.2t because this is a two-tailed test. And I can just tell it 0.05 and it knows to cut that in half and all of that. And then I can say 150, take away 1. There we go. That's my critical value. Now, if you're stuck with the old Excel, it's going to take me a second to remember this. It's t inverse. And then I think you still want the 0.05 because that was the problem with the old one, is that it always does two-tailed no matter what. And then this minus 1, cross your fingers. Yay, it's the same. Okay, so that's the deal with the 2t on the new one. T inverse dot 2t is the same as the just regular t inverse on the old ones. So that was kind of annoying in the old ones because if you weren't working with a two-tailed test, you were in trouble. Because if you're working with a single-tailed test in the new Excel, you don't have to do the .2t thing. All right, let's go back, shall we? Critical value done. Boom. So we found the critical value. So the critical value. Oh, you know what? Let's draw it on the picture. Haha. There it is. Let me think. There we go. Okay, so we found that this one was 1.97. I think that's what it was. 1.976. Okay, 1.976 over here. So this one over here is negative 1. Oops. Hold on. There we go. Negative 1.976. So there's our two critical values. Let me bring them back in. And that picture is way too big. Yes, it helps if you make sound effects as you do. Okay, so there we go. There's that. Now our question is our critical value in the critical region? Or, excuse me, I'm losing my mind. Is our test statistic in the critical region? So look at our number. It's negative 3.29. That's way over here in this little blue tail. So we are going to reject H naught. Reject the null hypothesis. Because, and since it was a two-tailed test, the reason we're doing it is because our T0, which was equal to negative 3.29, is lower than negative T alpha, which was equal to negative 1.976. In other words, it's in the critical region. All right, so that's the classical method. It's a lot of work because you've got to use Excel and the t-inverse functions in order to find these critical values. All right, then we'll come back next time and we'll do the p-value method and we'll finish our step 6. All right, so I'll see you then.